Hi, in the last video we talked about the parabola and its basic features. Before we do some problems on parabolas, I want to draw your attention to something though, just for a moment. We talked about the standard parabola and we talked about the standard equation for the parabola, y squared equals 4ax. Now, I want to draw your attention to something. This equation refers to a specific kind of parabola with specific characteristics. This refers to a parabola that's pointing towards the right with vertex at 0, 0. But that's the standard parabola. You know that there are other characteristics a parabola can take. This is a possible parabola, this is another parabola, this is another parabola, and this is another possible case. You see, there are various orientations that a parabola can take. The vertex may not be 0, 0 either. It could be 1, 2, or it could be 5, 10. So the characteristics of the parabola can change. Now, when the characteristics of the parabola change, i.e. when we're not talking about the standard parabola, this equation, y squared equals 4ax, may change slightly. It'll still have the overall gist of y squared equals 4ax, of course. That's one of the basic characteristics of the parabola. The overall tone of the non-standard parabola that we might come across will always be more or less of this form, but with some slight alterations. I've listed a few of them here. So instead of having y squared equals 4ax, you could have y minus 1 squared equals 4ax. You could have a slight constant inserted here on the y side of the equation. You could have a slight constant inserted in the right side of the equation with the x, like here, y squared equals 4a times x minus 3. You could have a combination of these two. You could have a constant on this side and a constant on this side. The x and y's may even swap places, like in this case, x squared equals 4ay. You've actually come across this fourth case before at school. You've come across this parabola before, y is equal to x squared. You've come across this before. This, believe it or not, is a non-standard parabola. It's not of exactly the same form as y squared equals 4ax, but it's similar because you can rewrite it as x squared equals 4ay, which is similar to y squared equals 4ax. And so there are a number of ways that the standard equation for a parabola can be altered. And that principle can be applied to all conic section equations. All conic section equations, normally, you'll come across the standard case, but in problems you'll come across non-standard cases. So the question then arises, how do you tackle the situation of a non-standard conic section? I thought we'd first begin by looking at an example, which I'm sure most of you can already do. I'm going to talk a bit about a circle problem here. Remember in the first video, we talked about the standard circle which had center 0, 0. And we said that when the center is 0, 0, the equation of the circle is x squared plus y squared equals r squared. But we also said that circles are often non-standard as well, and they may not have center 0, 0, they might have center AB. So, and we said when the circle is not standard, the equation changes slightly. It becomes x minus a squared plus y minus b squared equals r squared. As you can see, the two equations are very, very similar in the standard and non-standard case, but there are slight alterations when it's non-standard. So we're going to do a problem about a non-standard circle and apply the same principles that we use here with non-standard problems involving other conic sections. You're given a question in your practice sheet actually. Find the center and radius of this circle, x squared plus y squared plus 8x plus 10y minus 4 equals 0. Most of you will look at this and realize immediately it's not a standard circle because it's not of the form x squared plus y squared equals r squared. But what most of you will do is you'll say, okay, this is a sort of a messy, untidy equation. Let me try and rewrite this equation in standard form. So, i.e. in a form that resembles this form, and then maybe I can solve the problem. So what most of you will do is, you'll try completing the square, like I've shown here, and you'll rewrite it in the form x plus 4 squared plus y plus 5 squared equals 45. Once that's done, you can tell that this resembles this form quite well, and it looks much neater than that. Once you've rewritten it in standard form, you can solve the equation much more easily. You can immediately tell the center is minus 4 minus 5, from this side of the equation, and you can tell that the radius is the square root of 45, which is 3 root 5. I know this problem is something most of you can do, but the objective of going through this problem was to emphasize and make you appreciate that when you have a non-standard problem, which will be the case in your exam, you will have to manipulate your knowledge to try and tackle the problem. And that's usually done by, if you're given a messy equation, by rewriting it in standard form. And once it's in standard form, you'll realize that it's much easier to solve the problem. We'll apply this principle now in the next video where we do an actual parabola problem. Okay? Thank you for listening.